Hello friends, today we are going to solve a design problem on bevel gear. This problem was asked in your university examination 2018-19. So we are going to solve this question. Okay friend, the problem is a pair of straight bevel gear is mounted on a shaft. The shafts are at right angle. The number of teeth on pinion and the gear are 40 and 65 respectively. The pressure angle is 20 degree. The pinion shaft is connected to an electric motor developing 16.5 kilowatt power at 600 rpm. The service factor can be taken as 1.5. The pinion and the gear made of steel, which is having ultimate tensile strength 580 Newton per mm square, and these gears are surface hardened to 350 bhn. The gear are manufactured in such a way that error between two matching teeth is limited to 21 microns. The module and face width are given as 6 mm and 50 mm respectively. That means the module is 6 mm and the width of the teeth is 50 mm respectively. We have to find out the factor of safety against the bending and pitting. So what we will do, how we start this question. Any design problem, you have to start with the given data. You will write always first the given data. So the given data is the shaft angles. That means the shaft are inclined at 90 degrees, so theta is 90. The number of teeth on gear is 65. The number of teeth on pinion is 40. The pressure angle is 20 degree. The ultimate tensile strength, which is given 580 Newton per mm square, we can write down in megapascal. So 580 megapascal. The hardness, the gears are surface hardened. So the hardness of the gears is 350 bhn. So, and the error when they are matching with each other, the error between matching is 21 into 10 to the power minus 3 mm, because the error is given as 21 microns. Okay, the power to be transmitted is 16.5 kilowatt at an rpm of 600 rpm of pinion. The service factor is given as 1.5 and the module is 6 mm. The width of the teeth are 50 mm. Now we are going to solve this question, and how we'll proceed. We'll write down first the what we want to find out ultimately, and we want to find out ultimately the factor of safety against bending. Once you write the required uh, term which has to be determined in the question, you will have a clear picture of the question how you will proceed, because when you write the formula for that particular variable which is to be find out, you will start thinking that what is not given and what we have to find out and how it will be find out. Okay, so we have write down the factor of safety against bending is equal to ultimate strength divided by design strength. So ultimate strength is given. What we have to find out? We have to find out the design strength. Okay, and so if you want to find out design strength, the design strength is nothing but ultimate strength divided by factor of safety. Okay, now how we can find out this design strength? If we see the Lewis equation for the bevel gear, which is given as design strength into Lewis form factor y, design strength multiplied by Lewis form factor y, multiplied by pi, that is 3.14, multiplied by width of the teeth, multiplied by module of the gear, multiplied by uh, term 1 minus b by L, where L is the cone distance, and multiplied by dynamic factor. Okay, so if we see this equation, this is the governing equation for designing the bevel gear. Okay, when the gears are in the static position. Okay, these gears are, when we are considering the gear in the static position, they are having the bending load. Okay, so in case of, and we include in this the Lewis equation Cv to consider the dynamic effect also. Okay, so Ft is sigma d y into pi into b into m into 1 minus b by l into cv. So what is given in the question in this equation, we see what are the variables are given and what are the variables which we have to find out. So if we see sigma d is not given, so that is the main thing which we want to find out the factor of safety, because ultimate strength is given. Okay. Second is Lewis form factor. This Lewis form factor is also not given. Width, that is given 50 mm. The module, that is given 6 mm. Width again given. This L is not given and this CV is not given. So what we have to find out in the preceding steps, in the following steps, are the Lewis form factor, the cone distance, and CV. Once we are able to find out these values, we can find out the sigma d also. Okay, so we will try to find out one by one. First is, when we are using the Lewis equation, we have to decide for which component we have to design. That means I have to design the gear or I have to design the pinion. So we have to check this. Okay, but here, as the material for the both pinion and the gear are same, so there is no need of checking that gear is weaker or pinion is weaker. When the material is same for both gear and pinion, it is obvious the pinion will be weaker because size of the pinion will be lesser. Okay, that we have studied in when we have talked about the spur gears. Okay, now y can be found from the equation as we have used in the spur gears. Okay, and this equation is given uh, in your data book, the data book which we refer, that is machine design data book for written by Reddy and Mahadevan. Okay, so the equation for y is given in your data book at page number 163, equation number 12.17b. This is the snapshot of these equations. So these equations are dependent upon the pressure angle. Here we are having the pressure angle 20 degree. So we will consider 20 degree involved teeth. The equation will be 0.154 minus 0.912 divided by Z. But when we are using this equation for the spur gear, we must be careful that we have to convert this actual number of teeth by the virtual number of teeth, because when we are using the spur gear equations in the bevel gear, we have to convert that spur gear into the equivalent spur gear. Okay, now we will use this equation. So ZEP is equal to, if we want to use this equation of y, so we need what? Z equivalent, that is Z equivalent on pinion or Z equivalent on gear. Why we are calculating ZEP, as we do not need this ZEG here, but we are calculating that. I will tell you later why we are calculating here also. So ZEP is equal to ZP by cos del P. And what is ZP and cos del P? ZP is the actual number of teeth on the bevel gear divided by cos of the pitch cone angle of the pinion. Similarly, ZEG is equal to actual number of teeth over the gear divided by cos of the pitch cone angle of the gear. And how we can calculate it? If we see the matching of pitch cone of two gears, this is the pitch cone of the pinion and this is pitch cone of the gear, and this is the pitch cone angle for the pinion. So if we want to find out this pitch cone angle, we can use this geometry. This is what? This is the radius of gear, and this is what? This is the radius of pinion. If we project this radius of pinion here, we will have this triangle. And if we are having this triangle, this one, you see the cursor of, you will be able to see the cursor of this mouse, that is this triangle. If you use this triangle, then we can easily find out del P, and del P is nothing but uh, dp by 2 divided by dg by 2. And similarly we can find out the cone length, and cone length is nothing but, if we use this triangle again and use the Pythagoras theorem, we are able to find out this length, cone distance L is equal to square root of dp by 2 whole square plus dg by 2 whole square. Okay, so now we will go further. This tan del p is equal to dp by 2 dp dp by dg, that is equal to dp zp by zg, and this will be equal to, because if dp is directly proportional to zp and dg is directly proportional to zg, we can write down this equation: dp by dg is equal to zp by zg, and we will have this del P will be equal to, by calculating the tan inverse of 40 by 65, you can calculate the pitch cone angle of pinion, that is 31.60. By using the same geometry which we have used earlier, you can find out the dash G, because the shaft are at 90 degree, so you can find out the value of dash G, that is 69.40. Now we are able to find out equivalent number of teeth on pinion and equivalent number of teeth on gear. Okay. Again, but our ultimate goal is to find out the Lewis form factor for the pinion. So by putting the value of ZEG, putting the value of ZEP, equivalent number of teeth on pinion, in the Lewis form factor equation, we will have the y is equal to 0.134. Okay, then what we have to calculate? We have to calculate the pitch cone distance L. So we will able to find out the L, as we have seen that L is equal to square root of dp by 2 whole square plus dg by 2 whole square. So we have calculated the L is equal to 228.96 mm. Further, we have to find out again, use this equation. So we want to find out right now what we want to find out. We want to find out the right hand side of the we want to calculate the right hand side uh, of this equation in terms of FOS. So this sigma d further can be written out as ultimate strength divided by FOS, that we will see in the next step. So what is remaining is to be calculated, that is CV, and CV we have taken from the data book. Again, the velocity factor when teeth are generated teeth. So we have considered a generated teeth. So CV will be equal to 6.1 divided by 6.1 divided plus V, and it will be it can be calculated as 0.44. This equation can be seen on in your data book, machine design data book, written by Reddy and Mahadevan, page number 174, equation number 12.86b. The snapshot of this equation is given here. So you can calculate the CV easily. Further, we want to calculate this CV, we need velocity, and the velocity will be equal to pi dp np divided by 60 divided by 1000, because we want to find out the velocity in terms of meter per second. So we have converted dp into meters, and what will be a dp? Dp will be equal to m into zp, and zp is given in your equation, module is given in your equation, so you can easily find out dp is equal to 240 mm. So we have find out the velocity in terms of meter per second, and that velocity comes out in 7.53 meter per second. By putting this value in the above equation, you are easily able to find out the velocity factor CV. Now, putting this sigma d in terms of ultimate strength, and this ultimate strength is 580. Okay, 580 megapascal. So we have converted this equation sigma d into FOS. 580 divided by FOS, because the strength is given in megapascal, so we have converted into 10 to the power 6 Newton per meter square. Again, the width is given in mm, so we have converted in meter. Again, module is given in mm, so we have calculated in meter and putting all the values. Okay, we are able to find out the right hand side of the equation. Once we have find out the right hand side of the equation, that will be equal to ft is equal to 8018 divide 0.68 divided by FOS. So we have able to find out ft in terms of FOS. Okay, that is factor of safety. Now we have to calculate the, to find out the FOS, we need to find out ft, that is tangential force over the your gear teeth. So ft is very easy to find out, that is power into service factor into 1000 divided by velocity. Mind it, power here, power is in kilowatt. Okay, p is in kilowatts, that's why we have multiplied by 1000. So we can calculate easily the value of ft, that is 16.5 into 1000 into 1.5 into divided by 7.53. So we are able to find out this value, and this value comes out 3286.85. So similarly, by equating these two equations, we are able to find out the factor of safety against bending, and that is comes out 2.44. The next part of this equation is, this question is, we have to find out the factor of safety against pitting. And what is the factor of safety against pitting? That is wear load divided by dynamic load. So there are two things to be calculated, that the wear load and the dynamic load. The equation for the wear load for the bevel gear is given as in your data book, equation number 12.89, page number 174. The snapshot of the equation is given here. So we can easily find out FW, and FW will be equal to D1BQEK divided by cos del 1. Here D1 is nothing but dP and del 1 is nothing but dP, del P. Okay, so D1 can be written out as 240, which we have calculated earlier. B is given here, QE is not given. Okay, so the formula for QE is 2 into equivalent number of teeth on the gear divided by summation of equivalent number of teeth and equivalent number of teeth on gear and pinion. Okay, so we are able to find out QE because we have earlier calculated the ZEP and ZEG. By using these equations, we can find out the value of Q, that is comes out 1.6. That's why we have calculated there the ZEG also, because to find out the del P, ZEG is not sorry, to find out the value of del P, oh sorry, Y, it is not required to find out the equivalent number of teeth on gear, but we need to find out the equivalent number of teeth on gear for finding out the Q, the ratio factor. Okay, now FW will be equal to dP into P into QE divided by cos del P. So what is remaining to be find out is K, and K can be calculated by two ways, either by formula or by table. If you want to find out the K by formula, the formula is given by the equation 12.31b, page number 167, or from table 12.16, page number 193. The snapshot of the table and the formula are given here. So if you want to find out the K by formula, you need to find out sigma ES, and you must know the Young's model of the material from which the gear and the pinion is manufactured. So sigma ES can be calculated by the formula 2.75 BHN minus 17. As the BHN is given in the question, so we can easily find out the sigma ES. The value of sigma ES will be equal to 2.75 into 350 minus 70. That will be equal to 892 megapascal. And Young's model of steel is very well known to us. That is 200 to 210 megapascal, 210 gigapascal. Mind it, in this equation, you have to put the Young's modulus of any material in terms of megapascal, because all the unit of this equation is adjusted as per the Young's modulus, which is to be put in this equation in megapascal. So we have to put the Young's modulus in terms of megapascal, not in gigapascal. So we have taken the Young's modulus of steel as 210 gigapascal. So we have converted it into the megapascal, that is 210 into 10 to the power 3 megapascal, and put the values in this equation, and we are able to find out the value of K is equal to 1.85. If you use the table 12.16 at page number 193, you will have the gear material as steel and pinion material as steel, and check the BHN for pinion material is 350, gear material for 350. You can directly find out for 20-degree teeth the K will be equal to 1.893. That is nearly equivalent to 1.85, which we have calculated from the formula. That means either you are taking the K from that table or from formula, that is same thing, nearly same. From here we are able to find out the value of FW, that is 41614.4 Newton. Another thing which you have to calculate to find out the factor of safety against pitting, that is the dynamic load. Okay. So dynamic load can be calculated from page number 174, equation number 12.88, and this is the equation for dynamic load. The dynamic load is equal to tangential load plus K3V into CB plus FT divided by K3V plus root CB plus FT. This is the same equation which we have used in the spur gear. Okay, so here K3 for in SI unit, we are using the SI unit, so we will take K3 is equal to 20.67. C can be find out again by two methods, by using the formula or by using the table. If you want to find out the K by using the formula, you can easily find out the C by using this formula, that is error divided by K1 multiplied by 1 by E1 plus 1 by E2. E1 and E2 is nothing but Young's modulus of material of gear and Young's modulus of material of pinion. We have taken the steel in the question, so E1 will be E1 and E2 are same because both the material the gears are made of steel. That pinion and gear are made of steel. So we have taken it E is equal to 210 into 10 to the power 3 megapascal. Again, here we have to put the E in terms of megapascal. Okay, and E is given in our question, that is 21 micron, and that is equal to 21 into 10 to the power minus 3 mm. Here we have to put E in terms of mm. Okay, and K1 is given for 20-degree full depth teeth, that is 9. So we are able to find out C directly, that is 245. Okay, this C is a unitless number. It is a factor, so it is a unitless. So it will comes out 245. Okay, now we are able to find out the value of FD, because in particular equation only thing which is not known is the error factor. So we have calculated the dynamic factor depending upon the machining error. So error is on the basis of error we have find out this error factor, so we can easily find out the FD, and FD will be comes out 11914.40. okay, and hence we are able to find out factor of safety against pitting, that is comes out 3.49. This is the complete solution of the question. In this question, what we have done, we have calculated the factor of safety and module and width is given in the question. Sometimes it may be the problem that the module is to be designed. In that case, what we will do, we assume the factor of safety. If design stress is not given, ultimate strength is given, we assume the factor of safety and calculate the module. Okay, and then that module will be checked for the wear load and the dynamic load as per the condition given in your questions. Okay, thank you. This is all for now. Thank you.